Hello friends, welcome to Catalyst Chemistry. As we discussed last class, important point about what line spectrum of hydrogen, or indirectly we called hydrogen spectrum. In that the first one is what Balmer means. Lyman first discovered the Balmer, but according to series Lyman will come first, after that Balmer, Passion, Brackett, and next one is what Fund. Okay. In this case what there are 5 formula are there, but finally conclusion formula according to what Redberg formula is nu bar equal to 1 by lambda, means nu bar means 1 by lambda, directly nu bar equal to you have to write, no problem, nu bar equal to R, after that 1 by n1 square minus 1 by n2 square, close the bracket. Okay, that formula you have to use for what Redberg constant means, just you have to bear in mind, otherwise in PU board they are going to give you what in a given things they will provide you the according to Redberg constant, we have to put the values, means if they will give in centimeter or if they will give per meter, you have to check that one. If they will give centimeter means what 109677 per centimeter they will give, after that in per meter according to SI system, that is 1.09677 into 10 to the 4 of 7 per meter. You have to check that unit and you have to solve the problem. Okay, that is important. In that compulsory, you know, the higher energy is having a what less stable, it can come down to what lower energy, the lower energy is what more stable. The electron is always not present in a what higher energy. Okay, it is stable in a what lower energy. Okay, that is what most important. If the lower energy is there, higher wavelength, if higher energy is there, lower wavelength, these two are inversely proportional to each other. Okay, in this class we are going to discuss two problems on what the line spectrum of hydrogen only, according to Balmer and according to Redberg constant we are going to solve the problem. Complete, I solved everything here only, just I am going to read out the things, just see here. In this case how to solve problems with help of the calculator, I solved just now only. Okay, just here in this case problem is in an excited hydrogen atom. The excited hydrogen atom, excited means what, just see here in this case I explained that point only, no problem. Here is electron is there. Okay, you know very about that in a line spectrum, this is a nucleus, in this case the electron revolving around the nucleus, the electron move from lower energy to higher energy. This higher energy is excited state, that higher energies indicate what, excited state only. Just here in this case, in the same both only, just I am going to pass some amount of energy. This electron move from lower energy to higher energy. Okay, this higher energy is indicate what, excited state. Okay, this is what ground state, we can say what ground state, this is what excited state. Okay, is it clear? In this case, in an excited hydrogen atom, an electron undergo transition from what, n equal to 2 to n equal to 1. Okay, that is what important, assuming the value of, means the electron move from what they are asking, in electron undergo transition from n equal to 2 to n equal to 1, means what, in this case this is what n equal to 1, this is what n equal to 2. If already excited state is there, excited state is always what, unstable, the electron not stable in excited state, means what, higher energy, it can come from, they are asking the electron undergo transition from n equal to 2 to n equal to 1. Okay, assuming the value, this is this value they are given, in what they are given SI unit per meter, calculate. After that they are given 3 points we have to calculate. Just I am going to remove this one. Okay, no problem, leave it. Okay, here is that, calculate. A, first the wavelength, sorry, the wave number of emitted radiations we have to calculate, first one. The second one is frequency, after that what, wavelength. First one is what, the wave number of the emitted radiation. In this case which formula you are going to apply? Obviously Redberg constant you have to apply, don't apply the Balmer, don't apply the what, Balmer, because n equal to 1 to n equal to 2 to n equal to 1 they are asking, no. If n equal to 2 last is there, that is Balmer, but in this case we have to apply Redberg constant formula. First I am going to solve this one. A, here A is there, formula you have to write nu bar equal to R, R is indicate what, Redberg constant. In that last video I solved what, nu bar equal to 1 by R equal to, that is also same, no problem. Okay, nu bar equal to R, After that 1 by n1 square minus 1 by n2 square, close the bracket. This is the formula you have to write. Okay, in examination they will give what, half marks for this one. Okay. Next, after that you have to fill all the values. Redberg they are given 1.09677 into 10 to the power of 7 per meter is there, no problem. After that n1 means what, n1 equal to what, this is n1, n1 equal to what, 1 square equal to 1 only. After that n2, what is the formula of n2, 2, 2 2s are 4, 1 by 4 is there, you have to take LCM, means you have to take this one, solve this one totally. This nu bar equal to 8.225 into 10 to the power of 6 per meter. This is the answer for what, first one. This is what answer. Okay, you have to solve with help of the calculator, you have to solve. Okay, no problem. First one is clear, very simple is there. Okay, next, after that second one, the frequency of the emitted radiation. You know what they are asking, you know, actually this is the what, excited state, this is the what, ground state. The electron move from what, higher energy to what, lower energy. It start what, emission of radiation. These radiations having a wave number, wavelength, frequency. I told last video, no. Okay, that is we have to calculate. Are you understanding? Okay, that is we have to calculate. Means what, actually it is very difficult. Generally you are going to ask how we are going to calculate. The electron higher energy is there, this is the lower energy is there. The electron move from higher energy to lower energy. When it is coming back from higher energy to lower energy, it start emission of radiation. That radiation containing how much frequency, that radiation containing how much wavelength and how much wave number, that point we are going to solve in this case. That is most important point. Okay, that the scientists are trying to solve all the problems and formula, means what, they are going to find out something, means they are very intelligent persons. Okay, that is why. Okay, nu bar equal to, this is the, in this case what they are going to ask, how much frequency, how much wave number is possible in this case, means this much wave number is possible. That is come from electron from what, n equal to 2 to, means what, in this case n2 equal to 2 to n1 equal to 1. The first one is clear. Okay. Next, second one, the frequency of the emitted radiation. After that what they are asking, frequency they are asking. Here is there B, you have to apply this formula, nu equal to C into nu bar. This is the what, formula. You know what is the definition of frequency, wavelength, amplitude. Amplitude is there. I think I explained or not. Okay, just see amplitude, just I am going to explain. Amplitude means, I am going to divert the topic now again. Okay, here is there like this, the ray move like this. Okay, in this case the distance between this one, this is indicate what, amplitude. This one is indicate what, height of the wave. What is the amplitude definition? Amplitude. Okay, some students are okay. Amplitude, the height of the wave, that is called what, amplitude. Okay, in this case we have to point out amplitude, frequency. Next, after that what, wavelength, velocity, all the definitions are important along with formula. Nu equal to C into nu bar. What is the value of C? That is velocity of light. Every electromagnetic radiation having the same velocity. What is that? 3 into 10 to the power of 8 meter per second. If you are going to write one more value is there, that is 3 into 10 to the power of 10, that is centimeter per second. Okay, that is easiest. This is SI. After that nu bar value here is there, you have to fill this one, make a multiplication, finally you are going to get this one, 2.4677 into 10 to the power of 15 hertz or per second. Okay, that is what, frequency. The next one is what, in this case the last one, what they are asking, wavelength they are asking. This radiation is also having a wavelength of emitted radiation they are asking. In all the cases just see emitted. Okay, means what, this one they are asking, emitted radiation is there, that is how much wavelength is possible. Okay, just see this is lambda equal to 1 by nu bar. What is the nu bar? Here is there, 1 divided by 8.225 into 10 to the power of 6 per meter. Here is per meter is there, it can go off what ray, go off what is that, meter. Okay, 121.57 nanometer. This is the what, final answer. This one is indicate what, final answer, 121.57 nano. Nano means 10 to the power of minus 9. You have to shift the digits. Okay, definitely we are going to get. First of all, do this one. Some students are going to confuse, you have to take calculator. First you have to calculate 1 divided by 8.225. Okay, you are going to get a 1 value. 10 to the power of 6 is there, it can go off act as a 10 to the power of minus 6. After that make a digit adjustment, you are going to get a this one. Okay, is it clear? Next, this first problem is over. The next second one, calculate the wavelength. In this case what they are asking, wavelength they are asking. Okay, calculate the wavelength of H alpha line for the hydrogen spectrum. Just here in this case particularly they are asking hydrogen spectrum. H alpha hydrogen spectrum means you have to use Balmer formula. Particularly they are going to use what? Hydrogen spectrum. There is no transition, no, we have to take directly. We have to, H alpha line is there, we have to take what? Directly. That is called what? Balmer. In this case the what Rydberg formula we have used, but in this case we are going to use what? Balmer formula, because they are not given n equal to 1 or n equal to 2 something, no, not like that. Okay, directly they are asking H alpha hydrogen. H alpha hydrogen spectrum means what? In this case here 2, n is always what? Greater than 2 only. Okay, just here this is a problem, the answer start from here. Okay, for the Balmer Rydberg formula is, for the Balmer, this is also Rydberg only, but particularly what? This is a Balmer related. Nu bar equal to R 1 by 2 square minus 1 by n square. Nu bar equal to 1 by lambda, that is also no problem. That is also you have to write. Nu bar means what? That is only. Here 2 square is there. Here n is what? Greater than 2. That is why n equal to 3. After that what? They are given what? Rydberg constant of what? Hydrogen value is there. Next you have to fill all the values. This is called R value. After that 1 by 2 square, 2 to the 4, 1 by 4 square means 2 to the 4, 1 by 4, 3 to the 9. This is, after that finally this is going to get a what? Nu bar. This one is value per meter. The wave number is measured in per meter according to SI. Next, after that the wavelength, what they are asking? Wavelength. Nu bar is there. What is the means wavelength of the H alpha radiation? Nu bar is there, lambda equal to, you know, nu bar equal to, here is there, nu bar equal to 1 by lambda. We know this one, nu bar. In this case what they are asking? They are asking wavelength. Make it correction like this. Okay, this formula you have to use here only. Lambda equal to 1 by nu bar, 1 divided by 1.5234. Okay, you have to take calculator. First you have to do 1 divided by this one. This 10 to the power of 6 is there, it will go upper side, act as a 10 to the power of minus 6. Per meter is converted into what? Meter. After that in this case what you are going to get this digit, what is the digit modification. After that 659 10 to the power of minus 9 meter is there, 659 nanometer. The wavelength is measured in what? Nanometer only. Otherwise in SI is there, it is measured in what? Meter only. These two problems are important. Make it perfect. Is there any doubt? Comment on the comment section. I will solve and I will post if you are confusing. Okay, okay friends. Up to this what? This line spectrum completed. The next one is what? Line spectrum still is there. Still derivation is there. That point we will discuss what? Bohr's model of atomic. Okay. Thank you.